you start the card?
Yeah. We have two link between switch 1 and switch 2, 0/19 and 0/20. Okay, guys, first of all, understand to bundle these two link or aggregate these two link, we have two options. You want to aggregate these two link on both switches, we have two option for aggregation. One is static and second one is dynamic. Definitely in dynamic we will have protocol. Yes or no? Yes or no? In dynamic we will have protocol. So we have two
Yes.
types of protocol in dynamic. First one is LACP, PAGP, and second one is LACP. Let me write like this. PAGP and LACP. PAGP and LACP. First of all, what is Ether channel? Ether channel is a technology which is used to bundle multiple link between switches. Why we need to bundle multiple links? We had already discussed yesterday. To increase the bandwidth. If we have a single link between switch 1 and switch 2, then one user will get only 100 Mbps bandwidth. So let's say 10 user is sending traffic of 100 Mbps at a time, switch cannot forward that traffic. Right. So if I am connecting two link, STP is blocking one link. A spanning tree protocol will block one link. If you are connecting 10 link between switch 1 and switch 2, a spanning tree protocol will block 9 link just to avoid loop. So that's why we come up with a technology called Ether channel. On a switch, on some platform of switch, we have 4 gigaport, and on some platform we have 2 gigaport. So we can use gigalink 2 for the bundling, so that we can get more bandwidth. Like on any switch, on switch number 1, if you will check interfaces, so interface, so let's say IP interface brief. So these are fast Ethernet link. You can see 24 fast Ethernet link are there and 2 giga link are there. So in real time you should use giga Ethernet link for Ether channel bundling. Okay, it depends on platform of switches. On some switches you will see 4 giga link, on some switches you will see 2 giga link. Is it okay?
Excuse me, sir. Have you started recording?
Yeah, I have started recording. And let's say guys, if I have 4 link between switch 1 and switch 2, let's say I have one more topology here, switch 1, switch 2, and I have 4 link. So we can bundle 2 link in one group and 2 link in another group also. We can bundle link like this also. But here again, a spanning tree protocol will block one logical link. If we have 2 logical links, so a spanning tree protocol will block one logical link. Maybe a spanning tree protocol will block this logical link. So instead of creating 2 group on a single switch, you should create a single group. In single group, we can bundle 4 links together. Getting my point? Now there is some requirement of Ether channel. Okay, we will discuss about PAGP and LACP protocol, guys. In PAGP, we have 2 mode. One is mode. This is protocol. PAGP stands for port aggregation protocol. port aggregation protocol. It is used to bundle multiple link between switches dynamically, and this protocol have two modes of PAGP. Is one is desirable and another one is auto. See, desirable port is the port which will negotiate the ether channel, and auto port is the port which who will always wait for the ether channel negotiation. Let's say between me and Abdul, I want to form a friendship. So Abdul is a guy who is always waiting for the friendship. If someone will invite him, then he will accept it, but he will never initiate the friendship with anyone. And let's say my mode is desirable, so I can initiate, I always initiate the negotiation, right? And Abdul is already waiting, so auto mode is always waiting for the ether channel negotiation. Let's say on switch number 1 we have configured desirable, on switch number 2 I have configured auto, then ether channel will form there. But if I will configure both side auto, then ether channel will never form, because both are waiting for negotiation. That when someone will negotiate, will initiate the ether channel, then I will accept it. In the same way, in LACP again we have two modes. LACP, one is active and second one is passive. Active is like desirable. Active will always initiate the negotiation and passive will always wait for the negotiation. Now the major difference between PAGP and LACP is PAGP is an Cisco proprietary protocol. It is an Cisco proprietary. That means we can run this protocol only on Cisco devices. Cisco proprietary. And second thing is we can bundle up to 8 links only. Getting my point? But if I will talk about LACP protocol, so LACP is an open standard protocol, and we can bundle up to 16 link in LACP protocol. We can bundle up to 16 links. Up to 16 link. So that is the reason why we are using LACP protocol instead of using PAGP. In most cases you will see we are using LACP, or we can use a static method. In a static method we have only one mode, that is on mode. So if you want to configure a static ether channel between switch 1 and switch 2, you have to use mode what? On. If you want to configure PAGP protocol, then you have to use mode desirable or auto, maybe desirable or maybe auto. One side desirable or one side auto you can configure. Both side you can configure desirable, but both side you cannot configure auto. And in LACP, if you want to enable LACP, then you have to configure mode active and passive. Got it? Like on this switch you can see I have link number 90 and 20. First of all, on 0/20 port I have some problem. Let me check my rack. 1 second guys. First of all, I am going to down all interfaces and then I will up only 90 and 20. So interface range f1/0/1, sorry, interface range f1/0/1 to 24 and say shutdown, and on switch number 2 also interface range f1/0/1 to 24 shutdown. I have done all interfaces of both switch. Now I am going to run no shut command only on 2 port. See, by default ports of router is down, so that's why we need to run no shut command every time, and by default ports of switches is up, that's why we need to run shutdown command on unused port. Okay, and then I am going to run no shut command on 0/90 and 20, say no shut. Here I have to say range. No shut, and on switch number 1 also I'm going to say interface range f1/0/19 to 20, say no shut. Soon these 2 port will come up. Okay, so CDP neighbor, just wait for some time, it will show you. And okay, till then I am going to discuss some requirement. Okay, now you can see there is switch 2 is neighbor on 0/90 and 20. See, if I want to bundle these two link, I will run command interface range f1/0/19 to 20 and channel group, then group number, and then mode. See, I have how many mode? Active. Active means LACP protocol. If I will use active mode, automatically LACP protocol will enable on this switch. If I will use auto mode, then PAGP protocol will automatically on. And you can see enable PAGP only if PAGP device is detected. And desirable mode, enable PAGP unconditionally. Unconditionally means this mode will automatically enable PAGP protocol. Then on mode is the static mode, and after that passive mode. Passive mode will also configure LACP. So active and passive mode is for LACP, and desirable and auto mode is for PAGP. Getting my point? Is it clear? Now there are some requirements of BTP. Ether channel. See, requirements of Ether channel. First requirement is, let's say you are bundling these two links, so a speed of both links should be same. A speed of both links should be same, then only Ether channel will work. If let's say a speed of 0/90 is 100 Mbps and a speed of 0/20 is 200 Mbps, then Ether channel will not work. This is the first requirement. Second requirement is duplex must match. We have 3 duplex, simplex, half duplex, and full duplex. So duplex should be same on both switches, then only Ether channel will work. Okay. Then third requirement is Ether channel standard must match. You will understand this. Ether channel standard means if you are running PAGP on switch number 1, then on switch number 2 also you should use PAGP. Ether channel standard must be same. Done. Fourth requirement is, these are the requirement of Ether channel. Fourth requirement is all ports should be access or trunk. If you are bundling two links, so either both ports should be access port or should be trunk port. Okay, so all ports should be access or trunk. If your let's say 0/19 is access and 0/20 is trunk, then also ether channel will not work, guys. Fifth requirement is trunk encapsulation protocol must be same, and these are the definitely these are the not requirement. Only these four requirements are there of ether channel. Any dot till here to anybody? Okay,
Yes.
clear. Okay, now see the configuration. First, a static mode. In a static mode, I will use mode 1, on 0/19 to 20. I'm going to say interface range, and I am going to say channel group, and after that group number 10, and then mode is on. This is the static method. Okay, you have to use same command on switch number 2 also, so that's why I'm going to copy the command, or I can use history command. See, creating a port channel interface, port channel group number 10, and do so history. I'm going to copy these two command, and let me paste these two command on switch 2. Fine, done. And so a spanning tree. In a spanning tree, we are able to see we have only port channel now. The physical interface has gone. Now a spanning tree protocol is working on port channel, and so ether channel summary. With the help of this command, I can identify I have bundled how many interfaces. Okay, and see there is some symbol like F1/0/90, and in bracket we have P. So this P is port in channel, right? That means this port is in channel, and here we have SU. SU stands for, S means it is a layer 2 ether channel, and U stands for what? In use. So layer 2 ether channel is in use. This is layer 2 ether channel. I will show you layer 3 ether channel configuration as well. And now I am going to, let's say, connect some computer to switch 1 and some computer to switch 2. Let's say router 1. Router 1 is connected with switch 1, and router 1 is connected with fast Ethernet 0/0. Here I am going to add it. This is the requirement. Here I am going to add, let's say, router 1, router 2. Here I am going to add router 3 and router 4. See. This is R1. This is, let's say, R2. R3 and R4. This is 0/1 interface, 0/1 of switch 1. This is 0/2 interface, 0/2 2 of switch 1 is connected with router 2. This is 0/3 interface of switch 2. 0/3 of switch 2 is connected with router 3, and this is 0/4 interface which is connected with switch 2, right? After that, this is 0/0 of router 1. This is 0/0 of router 2, and this is 0/1 of router 3, and this is also 0/1 of router 3. Now I am going to configure one IP address on all routers. Let's say this router have one IP address 10.1.1.1. You can use this router as a PC. You can consider this is not router, this is a PC. 10.1.1.2. Let's say PC is connected with switch 1, and then here IP address is 10.1.1.3, and here PC4 have IP address, let's say 10.1.1.4. 10.1.1.4. This is the IP address of PC4. I'm going to copy this diagram from here, because if I will open the console, then topology will be not visible for you. So I'm going to do one thing. I have copied the diagram, and I'm going to paste this in another whiteboard. Let's say I'm going to paste it in this whiteboard. Okay, so now topology is visible, as well as you can see console is visible to you. Yes or no? Now according to my topology, I am going to configure the topology, logical topology in rack. So R1 is connected with 0/0, so interface 0/0, and IP address is 10.1.1.1, 255.255.255.0, and say no set. And as I told you that I am not going to use 0/1 interface here, so I am going to shut down this interface. And as I told you that I am using this router as a PC, as an end device, so I am going to disable routing on router. So no IP routing. This command will disable routing feature on this router. Now this router will act as a end devices. In the same way, on router number 2 also, I am going to first disable routing, say no IP routing. This command will disable routing feature on this router, and interface F0/0. I'm going to say no set, and IP address over here is 10.1.1.1, sorry 2, and 255.255.255.0, and I am going to down interface F0/1 because I am not going to use this interface. Done. Okay, if you want to verify the IP configuration, how to verify? So IP interface brief. So IP interface brief exclude unassigned. We can use this command. You can see IP on fast Ethernet 0/0 is 10.1.1.1, and line protocol of this interface is down because switch interface switch F1/0 is down now. So we will up that also. Don't worry. On router number 2 also have configured the IP. Let me configure IP on router 3. Config T and interface F10/1, no set, and IP address 10.1.1.3, 255.255.255.0, and exit interface F0/0 shutdown, and no IP routing. Fine guys. After that, router 4, interface F0/1, no set, and IP address over here will be 10.1.1.4, 255.255.255.0. I'm not going to use 0/0 of this router, so let me down the interface, and I'm not going to use routing feature on this router, so let me disable routing. Fine. Now tell me, PC1 or router 1 can ping to router 2? No, first of all I have to up the interfaces on switch as well. So on switch number 1, 0/1 and 0/2 is connected with router 1 and router 2. So I am going to use range command again, 0/1 to 2. I'm going to say no set. Okay, I have up these two interface, and on switch number 2 I'm going to up 3 0/3 and 0/4 interface range f1/0/3 to 4, which is connected with router 3 and router 4. Say no set. Done. Now can PC1 ping to PC2? Yes. Now PC1 should ping, because between switches we have ether channel and all PCs have IP addresses. So all PC can communicate with each other. Like so, you can see router 1 ping 10.1.1.2. Router 1 is able to ping router 2. Yes or no? Yes, you can see it is able to ping.
Yes.
3. Yes. And 4. Yes. Why it is able to ping? And you know the bandwidth between switch 1 and switch 2 is now what? Go to switch 1. So interface f1/0/19. If you will check particular this interface, you can see the bandwidth of this link is 100 Mbps. Yes or no? I can filter the output, include bandwidth. Bandwidth is 100 Mbps. This is 100 Mbps. 30 is because it is in kbps, so that's why we have 3 more 0 here. It is 100 Mbps. In the same way, bandwidth of 0/20 is also 100 Mbps. So what should be the bandwidth of port channel which I have created? P10. Are you able to see 200 Mbps? Now we have 200 Mbps link between switch 1 and switch 2. Yes or no?
Yes.
So we have achieved the more bandwidth between switches with the help of ether channel. Yes or no? And this is the static method. This is the static method. In the same way, you can configure dynamic method. Now question is, how switch is deciding when router 1 is, let's say, pinging to router 3? How switch 1 is deciding that I should forward this traffic from 0/19 or 0/20? Because at the end, even I have logical link, and logical link bandwidth is 200 Mbps. But router will forward traffic from the physical link. It cannot forward traffic from the logical link. Yes or no? So how switch 1 will came to know whenever it need to forward traffic to switch 1 which link I need to use. Either it can use 0/90 or it can use 0/20. But how it will came to know that which link I should use? For that, guys, we have the concept of load balancing. So you have to understand load balancing concept. So till here, if anyone have doubt, please ask me.
It's clear.
It's clear to all.
I don't know. Ilham is not here.
Who is not here?
Ilham.
Oh, I also don't know why he is not here. Okay, leave. I think he is interested to watch video. Okay, guys, see one thing. When router 1 will ping to router 3, when router 1 will ping to router 3, source, there will be source MAC, there will be destination MAC, there will be source IP, and there will be destination IP. You all know this. You all know this, that whenever router 1 will forward traffic to router 2, in the traffic, in the packet, there will be source IP, destination IP, source MAC, and destination MAC. Yes or no?
Yes.
So how many link we have between switches? We have only two link.
Two links.
So two link, to represent two link, switch needs one bits value. Switch needs one bits value. Bits can be 0 or bits can be 1. So do you know what it will do? It will check the source MAC address. What source MAC address is coming in the update? First of all, you have to check which algorithm by default it is using for load balancing, because we have again multiple algorithm for load balancing. So port channel, ether channel, and put question mark ether channel and load balance. That's it. So which algorithm by default it using? Is using load balancing operation state source MAC address. It is using only source MAC address for load balancing. So when switch 1 will receive traffic from router number 1, what will be the source there? Source will be router 1 MAC address. Router 1 MAC address is 0/0 include by. You can see this is the MAC address. This is the MAC address of router 1. So it will do what? It will convert this MAC address in binary. Sorry, I think I have copied wrong information here. 3 field is there only, na? This is the MAC address of router 1. Why it's, let me check why it's doing like this. 0079547, after that 000C38. Only this is the MAC address. Let me verify again. Okay, 8 only. This is the MAC address of PC1. Yes or no? Guys, it will do what? It will convert last value in binary. Last value is 8. So it will convert 8 into binary. So what will be the binary of 8? Anyone? Binary of 8.
Should be 0, 0, 0.
This one. This is the binary, na? This is the binary of 8.
8, yes.
And it is going to use only 1 bits because we have only 2 link. Let's say if we have 4 link, then it will use 2 bits, last 2 bits. If we have 8 link, then it will use 3 bits. So now I have only 2 links. So to represent 2 link, it need only 1 bits value. So it is going to use this bit with this bits. So this bit is what? 0. So it will use link number what? 1. It will use link number 1. Okay, if you want to verify how we can verify it, we can do one thing. On switch, I can check interface F1/0/19 and we can say include packet output. How many packet you have output from this interface? I can check like this. right? Like this. You can see how many packet have out from this interface. 507. 507. And clear counter fast Ethernet 1/0/19. And now I am going to check. Now you can see we have 0 packet out from this interface. Yes or no? In the same way, I am going to clear cont 20 also. Okay, and you can see on 0/90 we have 2 packet. 2 packet have out from F1/0/19. And how many packet have out from 1/0/20? 4 packet, right? Now I am going to send 1000 traffic from router number 1 to router number 3. Just to check router switch 1 is using which link. So ping and 10.1.1.3, and I am going to say repeat 1000. Okay, and now see on which port packet count is increasing, on 0/20 or 0/90. Packet count is increasing on which port? On 0/20. Packet have not increased on 0/90 port number. Yes or no? You can see packet output is 11. Only 11 packet is out from 0/90, and 1010 packet have out from fast Ethernet 0/10. That means router switch 1 is using which link? 20 link number. Okay. It is using which link number? Link number 20.
One.
Now question
Okay.
is why it is using link number 20. So as I told you that it will use link number 1. So in ether channel this is link 0 and this is link 1. Okay. Got it?
Yes, got it.
So this is how switches is going to perform load balancing. So ether channel summary. This is port number 0, this is port number 1. It is using port number 1 to forward the traffic. So ether channel and port number 10, let's say I'm running the command like this. Port port index. This is different thing. Port index is different thing. This is not in your syllabus for now. Here I want to see something else. That is this is also a verification command. We can see we have how many ports in this channel? 2, and group is L2, means it is an L2 ether channel, and maximum port that we can bundle is 8. In a static method and in PAGP we can bundle only 8 links. In LACP only we can bundle up to 16 links. Okay, leave. For now what I am going to do, I am going to check what is the MAC address of router 2. Router 2 MAC address, and see which ports it is using for router 2. So interface F0/0 include. This is the MAC address. In last value is 0. So for this also, for router number 2 also, it is going to use which port? it is going to use same port number, yes or no? So I am going to again capture, I am again going to clear the counter of fast Ethernet 0/0 and 0/1. Clear counter 0/20 and clear counter 0/19. I have deleted all the packet on fast Ethernet 0/0 and 0/1. Again I am going to check the packet on fast Ethernet 0/0 odd packet, and let me check output 0/20. From 0/20 also we have less number of packet output, and from router number 2 I am going to now send 1000 traffic to, let's say, 10.1.1.3 and repeat 1000. I've sent 1000 packet, it ping is working, and let me check which link switch is using. So switch is using which link? 0/19. This time also switch 1 should use 0/20 port number. No, because source MAC is this one. Source is still 000. It should use again port number. So you know why it is using 0/90 port number. It should use 0/20 port number, by the way. But now switch is performing load balancing for per packet. It will forward one packet from 0/19 and one packet from 0/20. Last time it's have forward one packet from 0/20, and now it is forwarding one packet of router 2 from 0/19. Okay guys, and so ether channel load balance, here we are able to see by default load balancing algorithm is source MAC. It should use only source MAC address for load balancing, but we can use IP address as well for load balancing. We can use IPv6 address also for load balancing. We can use source and destination MAC also for load balancing. How to change the load balancing algorithm? Ether channel port channel group number 10 and port channel load balance, and you can see how many load balancing algorithm we have. We can set destination IP address, means you should perform load balancing only on destination IP address. We can set source IP address, so we should perform load balancing only on source IP address. So let me set source IP address, source IP, right now. So ether channel load balancing, now algorithm is what? Source IP address. So it will perform load balancing on the basis of source IP address. And let me clear the counter on these two interface again. Hope you guys are getting me what I am doing. Actually I am clearing the packets on a particular interface.
Sir, I have one question. Like, if you like, is there any command available to clear or to finish all commands we have done, like in switch and router, or we have any
Yes,
configuration? Any configuration we want to finish, like same as like new switch or new
new
router?
switch,
Yeah,
reload.
reload. Just only reload.
Yes, reload.
Oh, that's
That's
nice.
it. Or if you want to set default configuration of interface, reload will do what? Reload will erase the entire configuration. Okay, but let's say on a particular interface, let's say on fast Ethernet 0/90 and 0/20, we have configured what? Ether channel. You can see, so run interface f1/0/19. On this interface we have run this command, channel group 10 mode on, yes or no? Let's say I want to
Yes.
set I want to remove all configuration from this interface. I don't know whatever configuration I did over here, but I want to delete everything. So I can use default interface fast ethernet 1/0/19. This command will set the default configuration which is in operating system. When you purchase the switch, that time whatever configuration was there on the switch, now only those configuration are there. Rest have deleted. So run interface f1/0/19. You can see all the command have removed from this interface. Yes.
If you write like reload, it do same thing as default configuration.
Reload will, here it's asking for yes or no, so I will say no. Once I will hit enter, it will erase all running configuration, all interfaces configuration, all the
Got it.
running
Got it.
configuration.
Yeah, that was good option. I didn't know this one.
But now I am not going to reload this.
Okay. Yeah.
So what I will do here, what I can do, I cannot do. Now I have to reload the router.
Yes, you can say yes. It should be.
See. Switch 1 is reloading. It will again reboot. It will again reboot the device. Actually, with the help of reload command, we have rebooted the device. And because of that, here you can see port channel is down. Because on switch number 1, you have removed the configuration. So IP interface brief. Your port channel on switch number 2 is down. Okay guys, see here, switch 1 is booting. In real time guys, please, you will never reload the device, okay, because there will be lots of configuration on switches. Whatever protocol we are discussing, like a spanning tree, VLAN, trunking, all configuration will be there. Whatever protocols we have discussed, there will be lots of password, by the way. Password, description, like this interface is connected with that router. Like, on switch number 2, I am on switch number 2. How I will came to know that switch 2 0/3 interface is connected with R3? Yes or no? So in real time, we will have one description on that port. Interface F1/0/3, and I have one description, and description will be this port. This port is connected to R3. Getting my point? And when I will run command, so interface status, so I can see on 0/3 port, I have one description. Description is what? This port is connected to. I have write only this. This port is connected. So run interface F1/0/3. This port is connected with R3. So interface status. In so interface status also we can see, but here it's showing me only source information, right? Not full information is there. So, and show interface status include connected. I should use this command to check only connected interfaces. So you can see these are the connected interface, and on this interface there is one description, so I can check detailed information of this port. So interface F1/0/3. So like this, if I will open this interface in detail, we can see description is description. This port is connected to R3. So in real time on all interfaces you will have description, lots of configuration, so you will not reload the devices. See, again I have access of router number 1, but I have lost my all configuration. So ether channel and so ether channel summary, you can see there is no any configuration now. Got it?
Yes, got it. Yeah.
Again I am going to configure ether channel. So ether interface range f1/0/19 to 20. Where range and channel group 10 and mode is on. Okay, and let me disable the interfaces. Interface range f1/0/3 to 3 to 18, and after that 90 and 20 I am using, so 21 to 24. See, I can use range command like this also. I can use range command like this also. What happened? Interface range f1/0/3 to 18 and f1 slash, sorry, here it is 1/0/1/0/21, like this. I have selected how many interface here. I can configure multiple interfaces together with the help of range command. See, I have selected interface 0/3 to 18 and again 21 to 24. I have not select 0/1, 0/2, 0/90 and 0/20, and I am going to say shut down to this port because I am not using this port. Getting my point? Okay, is it clear?
Yes, it's clear to me.
So ether channel summary. Okay, and I want to change load balancing algorithm. So channel port channel group load balancing algorithm. What I am going to say? Source IP, and on switch number 2 also I am going to set port channel load balancing algorithm is source IP. Done. Now it will perform load balancing on the basis of source IP address. So see, what is the IP address of router 1? Router 1 IP address is 10.1.1.1. So it will convert 1 into binary, last value in binary. So binary of 1 is 00001. Yes or no? So it is going to use last bit. Last bit is 1. Only this bit because we have only 2 link. So if port is 1, then it will, if value is 1, decimal value is 1, then it is going to use port number 2. Port number 2 means port number 20. Port number 20. So if you want to verify here on router number 1, sorry, on not router 1, PC1, first of all I am going to clear counter interface or fast ethernet 1/0/19 and 1/0/20, and after that so interface f1/0/19 and say include packets output. See, output packet on this interface is 4 and output packet on fast Ethernet 0/20 is what? 5. I am going to send some 1000 ping traffic to PC number 3 or router number 3. 10.1.1.3 repeat 1000 or 100 is also fine. Packet count is increasing on which interface? On 0/19. That means it is using 0/19 link. 0/19 link, it is using 0/19 link. When, because here you can see value is 1. Okay, whatever value it will get, I think it is using same port. Exactly. When router 2 will ping, so see, binary of 2 is 0 0, binary of 2 is 0 0 1 0, right? So here value is 0, so it will use port number 19. It should use port number 19 then. Sorry, it should use port number 20. If value is 0, then it will use port number 1. So 1 means 20. If value is 1, it will use port number 0. Okay. So let me do one thing. From router number 2, I am going to send 1000 packet. Guys, here I am getting some wrong output. I don't know why I'm getting some wrong output, but concept is same only, right? Load balancing can be done in ether channel on the basis of source address and 1000, and after that I am going to check from which interface it is forwarding traffic. From 0/19 only. For both computer, for router 1 and router 2, it is using link number 19. When I am performing load balancing on the basis of source address, it is using same link. Okay, I will check it why output is wrong here. I will tell you later about this, but this is all about ether channel. Now we don't have anything left in ether channel. Only configuration is left that you can configure like PAGP and LACP by yourself, because changes here only. Mode, interface, range F 1/0/90 to 20, and channel group number 10 and mode. If I will use mode desirable and auto, that means we have configured automatically PAGP will enable. If I will set mode active or passive, automatically LACP protocol will enable. Getting my point? So interviewer will not ask you these questions detail, like how load balancing happen in ether channel. They are going to ask you very simple question like what is ether channel, how many protocols are there, how many method we have to configure, what are the requirement of ether channel, these question only. Okay,